All right, now we have two more examples we're going to look at, and we're going to look at what's called piecewise functions. And as you can see, we've got functional notation f of x equals, and then there's typically either two equations or sometimes three, which is going to create the number of pieces in a piecewise function. And you have to make tables to do these, and we're going to look at number 29 here. And I have -1, and this is a key piece of information, and f of x is equal to x plus 1 if x is greater than 1. What you need to do is make tables for each line that we have here. In this case we have 2, which is going to create two pieces to our graph. So, and we want to think of f of x like y. So what I'm going to do is I'm going to look at the top line in that, and I really have f of x is equal to 3, or y is equal to 3. And we want to look at if x is less than negative 1. We're only using this if the x values are less than negative 1. So we're going to make a table here. And we want to look at x less than negative 1. Even though it says less than negative 1, we have to look at the decimals. We can't just start with negative 2 because we're not looking at only integers. We have to put negative 1 in our table. And that's just going to create what we call an open circle there because it's just less than negative 1. So it's going to be those fractions or decimals up to negative 1 but not including it. Okay? And notice we are going to take x less than negative 1 here. Well, we can go negative 2. Now with the rational function ones, you had to try some decimals in between. We don't really have to do that for these. You can put integers in your x column, but we're looking at ones less than, so we're getting smaller. And I'll put about 4 values in there. So now, we can't actually substitute negative 1 into this because there's no x. So it's just saying that part of it's going to be constant. It's 3. So at negative 2, we're going to be 3. At negative 3, we're going to be 3. At negative 4, we're going to be 3. And this would continue, negative 5, and so on. So that part of the piecewise function is going to be constant. Okay? Let's create our second table, and then we will, basically let's graph this first. So at negative 1, we're at 3, but it's got to be an open circle. So at negative 1, we're up here at 3, open circle. At negative 2, we're at 3. At negative 3, we're at 3. So what's going to happen is this is going to be a constant graph, and it's only going to arrow in that direction. It kind of starts at that open circle at negative 1, 3, and goes that way. So we've graphed this top piece right here. Now we're going to make another table for kind of our second line right here. And it is y is equal to x plus 1, okay, or f of x equals x plus 1, if the x values are greater than 1. Okay, so it just says greater than. We're going to start at 1, and that's going to kind of create an open circle there at 1 and whatever we get when we plug it in. And we're plugging it into x plus 1 here. And we're going to pick values bigger than 1. So 2, 3, 4, and so on. So when I plug 1 in here, y equals x plus 1, we have 1 plus 1. It's going to output a 2 there in the y. When I put a 2 here, 2 plus 1 is going to output a 3. When I put a 3 in, 3 plus 1 is 4. When I put a 4 in, 4 plus 1 is 5, and this. Okay, so let's graph this at 1, comma, we're going to be at 2 with an open circle. So we're right there. At 2, we're at 3. So 2, comma 3 is going to be right there, approximately. 3, we're at 4. So we're going to be up here. 4, we're at 5, and so on. So what's going to happen is it's going to start at that open circle, and it's going to go up like that. All right, so there's our two pieces to our graph for this one because we had two lines in this piecewise function. Now we have to identify domain and range. The domain is what x can be. Now if you notice, we've got a little gap. Okay, we don't have anything any part of the graph in between these x values from -1 over to 1, there's nothing. Okay? Now, it's not going to be all reals then, because when we're between -1 and 1, there's no part of the graph, either piece. So what we're going to do is we kind of have to describe it in two parts. We describe what I have as my black one, which is x is less than -1, or then we're going to describe kind of my red piece that kind of increases to the right here. That starts at an x value of 1, so x is greater than 1 because we're getting to all these x values over here, and it continues infinitely up that way. The range is what y can be. Now, if you notice this black horizontal segment on the left piece, actually is a y value that's included in this part of the graph. Okay, if that would have been down like in the negatives, we would have had to include that. But basically, if we say all y values that are graphed, the lowest y value here is at 2, which is where this open circle, oops, that's an open circle right there. And its y is bigger than 2. Again, this is an open circle right there. Okay, and when we say y is bigger than 2, that's including the values of 3 that are on that constant part of the piecewise function right there.